Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about tire recycling. So let's dive right into it. Now, what exactly is the problem? Well, problem is that we are using tire like there is no tomorrow. Like this is a real photo, not CGI. And we are using so much of it. And given the fact that it is taken away from human view, we have no actual idea how bad this is. Like this is on the same level as basically plastic pollution. So it's brutal. And you may be like future technology. No, even EV uses rubber tires. So it is a seriously serious ongoing problem. And you may be like, what about if we have something alternate, better? No. This puppy went through almost a century or even more of R&D to be this good. So fundamentally, there is no cost-effective and better replacement. Flat out, don't even think about it. Could there be some alternates? Yes. Would they be cost-effective? Hell no. So let that be very clear. And why tires are so hard to recycle? Because we want tire to be unrecyclable. We want tire to be badass, indestructible. Think of it this way: tires can be so strong that they can withstand around 150 degrees Celsius hot air inside them. Especially if you are in India and you're driving in any concrete highways, it could get that hot, and even hotter if you are talking about aircrafts and all that jazz. They have to use nitrogen in them in order to not go boom. So effectively, everything that makes a tire that good in working makes it hard to deal with in terms of recycling. It's we wanted a material from scientists. Like, scientists, give us a material that nature cannot degrade. Scientists like plastic. That was awesome, but problem is like now nature cannot do anything of it. So the same thing that makes tires so amazing is the same thing that makes it so flat out non-recyclable. And tires have three core components. They have rubber, steel, and fabrics. So a rubber part is given the fact that it's mixed together, that's what makes it so problematic. Not just if it was rubber only, not a big issue. If it was steel only, not a big issue. If it was fabric only, minor issue, but still manageable. But if you mix all three, yeah, good luck. So this sandwich makes it very difficult to deal with. So our first tool is mechanical tool, meaning we use raw physical power to just sort it out. What does that mean? That simply means you cut it, you shred it, and you shred it some more. So you will start with big tires going through big chunkers, and then you will send small tires to small chunkers, and then you will have like small, even smaller. So you try to get it as small. When you start to separate core components, meaning strands of steel will start to pop out, fabric strands will start to pop out, and then you will have proper sorting, meaning you will use magnets to remove basically steel. You will use basically water solubility to remove water and other things. There are things that you can use to sort things out, gravity and all that jazz. So that is the way of getting rubber out of tires. Now here's the deal. It works. That's awesome. No air pollution. That's super awesome. But the rubber is not virgin. What does that mean? That simply means every time that you are shearing rubber apart, it is creating pores in that. It's a structure that you are tearing apart. It creating pore in that. Now that pore is making love to atmosphere. Consequence, there are oxygen. There are materials from our atmosphere that is going inside that. Meaning the rubber quality is far degraded, meaning no company will make new tires from this. And if you are like a luxury car brand like Lamborghini and all that, they're like, no bro, no, we're not gonna even mix this. Meaning you can, like in cheap cars, you can find tires that have some percent of recycled rubber that will be from there, but nobody wants to use this. It is used in secondary market basically for asphalt addition, things of that nature. Meaning this is rubber but not desirable rubber. It does work. Steel is recovered in very large concentration. Rubber is used in some other fillings and buffers and all that jazz. It does work. It's just that it's not awesome rubber. It's not like aluminum recycling where it's like aluminum goes in, aluminum comes out. Here's like rubber goes in, low quality rubber comes out. So there are some limitations. That's why even though this can be done as early as like 1980s, nobody is actually doing it because the rubber output is like not really that sellable. So this is the mechanical sorting. You can see this part many ways. Then we come to the pyrolysis option. That's the option number 2, which is also called as chemical recycling. Now what is we are doing? We are doing the same process as step 1, shredding and sorting it out first. Then the rubber part, we are cooking that rubber in basically a cooker without air, or specifically without oxygen. Now, how hot you want to? Generally 600 degrees is basically hot. We are talking some serious hot. And if you ever heard like people making, basically fuel out of plastic, that's the same thing, pyrolysis. It's a known scientific phenomenon. Is that if you cook this puppy properly, you will have a lot of flammable volatile gas. What does that mean? That means it's creating cooking gas. Again, not methane. There are other components also. So you take that gas, you set it on fire on using itself. So meaning the input has the enough energy surplus that the whole process is self-sufficient, meaning the fuel is rubber itself. So you put it your tire, of course shredded tires, and hopefully removed of all fibers and basically steel, and then it creates volatile gas. That volatile gas burns and then provides the heat cycle in this. Now it's energy sufficient, meaning any plants running this system does not need fresh energy. It's like, bro, we are energy sufficient, and it cooks it properly. If done correctly, you can have multiple outputs. Primary output is rubber, output is virgin stock, meaning because it has gone through some quote unquote chemical process, it's stock that you can sell to other manufacturer, and it will be classified as virgin rubber, meaning you can mix it, you can just use it raw without ever any worry. Meaning if your country is consuming a lot of rubber, and let's say you are India and you are getting rubber from Germany and all that, just we can just keep, we don't even need to have forest for rubber anymore. It's like, bro, we just keep recycling it. We don't have to worry about it. Again, it does lose some percentage, again, gases and all that jazz. You are losing some percentage of it, but if done correctly, you can have like very good recycling efficiency. And it does have other options, meaning depending on the temperature, depending on the structure, you can create a scenario where it also gives a rudimentary petroleum or rudimentary crude oil benefit. Those are also desirable in some scenarios. Some scenarios, like in India, we don't actually try to get rubber out of it, we try to get crude oil out of it, or diesel out of it. At that point in time, it's just like very easy to sell. So depending on your market condition, you will set this cooker dependingly what exactly you want. In some scenarios, they're like, bro, we want raw rubber. In some scenarios, we want crude oil. Some scenarios, they're like, we want diesel. You can tune the temperatures, feed rate, all that jazz. But it does have air pollution. Be mindful of that, because again, those volatile gas, they are not clean methane. They do have some content which may require basically flushing this through some flue gas treatment in order to get clean exhaust output. That's why like burning rubber is not advisable. It does have a lot of other content, specifically sulfur. So sometimes it's generally desirable to not do this, because it does consume energy, but it does give good output and products that are far more sellable compared to the first method. But the air pollution is a serious concern. So in Germany, only qualified companies can even attempt this, because air quality assurances are difficult to do. But it does work. It's a simple system. It does work. Even India has it. Even China has it. It does work. And this is what people call chemical, processing. Then we come to the latest hope for humanity, that is cryogenic. Every time we are using heat to do things, but here's the, you can do the same thing in reverse also, meaning you can cool it down. Now using liquid nitrogen to do it all in one go, meaning this is a research paper that you can find on Google, is that you take a rubber tire as in, you dunk this puppy into liquid nitrogen, let it properly cool down. They have created a timeline for that, and then you put in a hammer shaker and bam, you get rubber output. Now it allows very good separation, meaning your steel is separated, your fabric is separated, your rubber is separated. Very good separation. It's like amazing kind of separation. And rubber that is created out of it is virgin. Now you're like, wait a minute, we use physical force here. Why the heck this is virgin rubber compared to rubber that was created in mechanics? The same system. The shear vector here is very little. So if you look that rubber under microscope, you'll find it's a very low porosity, meaning oxygen has not penetrated into too much where it's quote unquote contaminated. So it's really good. The material coming out of it is raw stock, meaning you can sell it to other rubber manufacturer and they're like, dude, we're not gonna give you less money, we're gonna give you exact same money that we're gonna give any other vendor. So this is a company, video provided down below. Like this company is like extruding rubber out of it, and you can see like this rubber mat is actually sold as a rubber raw stock, meaning you can make whatever you want out of it. Like it's no longer limited. It's like, bro, it's just raw rubber. Do whatever you want to make pencil rubbers, go YOLO on it. You want to make tires, go YOLO on it. You want to make rubber mats, go YOLO on it. Like this does not, this is what we want actually, that we don't have to worry about rubber after. Again, efficiency is also very good in this. No air pollution, that's also amazing. But there is too much secrecy, meaning even though there is video of this plant, nobody actually knows how much energy they are consuming in order to make the liquid nitrogen, do the crushing and all that jazz. Data is missing, and many scientists have pointed it out that we know the fact works. We know that part is sorted. Do not think this is black magic. We know this works. It's just that efficiency, meaning how much energy you are consuming for that. Like if the energy content is higher than what you will spend in order to make virgin rubber, then this is pointless. So without having a third-party verification, this sort of system is like unknown. Again, science says it should work, but unless we have real-world data, and every company that is doing this is like top secret, patented. Even in the video itself, like they are just vaguely talking about, like, we use cryogenics. They don't even go into like they are using liquid nitrogen. And maybe they're using something different, but likelihood is very low. So this documentation you can find. So this is option that people want to have, because it's just like using cryogenics, using some physical force, and voila, full material recovery. That's what we want eventually. So what are our current limitations? Well, our current limitation, we are not doing it in scale, because I specified the mechanical system could have been done long ago, but it's not that useful. Nobody has that much requirement of second-hand rubber. So not really desirable. Pyrolysis is becoming a thing, but unless done carefully, it's causing too much pollution, specifically in India. But again, that's something I can see scaling up. But the fact that cryogenic is a technology that does work, given the fact that no other company is sharing their information, that makes verification unknown. Without that verification, trusting on it is just like a gamble. So that's something that we do not know. And we do not know which option is the best option, because right now, hopefully cryogenics is the best option, does not consume too much energy, and if you have good thermal management, you can really run this plant on very little energy input. But we don't know. We're just hoping for that. And because we have to find long-term solutions, this is a graveyard of Kuwait, and yes, you can see it from satellite. Again, because it's a black thing against a yellow background, it's like, it's huge. It's huge. That's why I specified, like, rubber pollution is becoming something very serious. Like, again, because it's taken away from common sight, we're like, rubber is not a big issue. No, it is a idiotically large issue, and it's getting larger every year because we are selling more cars, even EVs, even there are some metros that also use rubber. So Paris. So that's why amount of rubber consumption is going exponentially, and the waste that we are getting is exponential. So we have to figure out a solution, either pyrolysis or cryogenic system, or maybe if we have nothing else, just might as well do basically mechanical system. We have to sort this out. So there are some limitations, and we have to act quickly before this becomes another plastic level problem. It's like, it shook me. It's like, can you see this from satellite? Yes, you can't see Palm Jumeirah and all that jazz from satellite, but you can see this. So this was my presentation on basically tire recycling. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.